Hello there. Would you like to learn today? Yes. You have come to the right place. My name is Professor Jethro van Hopper Cassava Helio Cordida Charged Kopf von Kason the Third. And today, on this show, we are going to learn. The name of this show, of course, is science. Today, we are going to find out the approximate wavelength and other material through diffraction gratings. You're probably wondering how we will do this. Well, I will break it down for you step by step. Step 1. We are not going to use steps in this science project because steps not as fun as say jog. We're going to jog through this experiment because learning is power. Jog 1. We are going to figure out D to be 100 nanometers using the laser pen at 660 nanometers if L is equal to 2 1/4 inches and Y is equal to 3 1/4 inches. Job 2. Marking the wall. Now, in order for this application to be useful, we must find some way to make it helpful to others. What if we were colorblind? Like so. Alright, now you go ahead and put your glasses on too. Here we are in our experimental lab. You see, here we have the light showing through a diffraction grating at the back of the room. Over here, you might not be able to see it well, but we have our diffraction pattern. As you can clearly see, the red pattern shows up right about here. So now that we have our diffraction painting on the wall, we simply come over here, mark the approximate halfway point of the red diffraction pattern. Over here, we mark that. We will then measure the pattern as soon as I find where I put my handy dandy measuring tape to be an approximate. That's big. Okay, that's good. And then we will measure that to be an approximate. Yes, about right. Jog 3. Finding the Y and L values. Using triangulation, we hypothesize that the angle between here and the point of contact for the initial light beam, the zeroth order, will be approximately 8 inches with a hypotenuse and 5 1/2 inches for the adjacent side to the angle, making the angle approximately 47 degrees. We see that this is a corner and not actually perpendicular to the source of light. Therefore, this value is not the correct distance to our Y. However, because we use triangulation and the sine law, we can determine that Y is in fact 128.5 inches from that wall, making the actual Y 164.16 inches from that X, perpendicular to the point source of light. Job 4. Finding the wavelengths. We find the wavelength by getting the Y value times the D value divided by the L value. Therefore, knowing through the Pythagorean theorem that we used to find the L of this wall, we know that L is 186.28 inches. Therefore, the wavelength is approximately 650 nanometers. It's actually kind of funny. This is in the approximate range of red light, so we know that this color over here, even though we are colorblind, is red light. This can be made to find any color of light. You simply find what distance it is and look it up on the chart that I shall provide for you. You should know what color the light is if you are colorblind. I am not really colorblind though, so I'm going to take this off. So finally, we see that the wavelength differed by only 10 nanometers than the laser we used on the pen, and therefore the theory works perfectly. In salvation of which we shall do a small little physics dance, I like to call it. Okay, that is all. Once again, thank you for joining Professor Jethro Van Hoffergaffer Kasabi Helio Cornelio Charged Park Van Kason for his experimental lab on infringement patterns. You may have noticed these patterns will become very useful. Maybe not for me or you, but for those who are colorblind, like our friends. Or maybe like dogs that cannot see. You know, like colorblind dogs. Did I guess all dogs? Well, thank you very much. And we look forward to having you again on Science.
There's a place up ahead and I'm going just as fast as my feet can fly. Come away.
Oh, physics. Hypotenuse. Derivative.